Welcome back to freehighschooleducation.com. Today we are going to do chapter 8.1 in Algebra 1, page 289, simplifying rational expressions. A rational expression is a polynomial or the quotient of two polynomials. This is the definition given in the book. Now, before we go into the rational expression, a rational number is any number that can be expressed as the quotient of two numbers. So the number 5, we can express it as 5 over 1. So it is a rational number. Now, as far as the expressions, x is a rational expression because we can express it as x over 1. X squared plus 2x plus 5 is a rational expression. We can express it over 1. However, in this chapter, we are not interested in all these rational expressions. We are only interested in those that have a variable in the denominator. Let's take an example. Here we have a few examples where we have a variable in the denominator. Our first concern is that the denominator should not be equal to 0, because in this case our rational expression will be undefined. So when we do any simplification or any work on these expressions, the first thing we have to put the exclusion. We are going to exclude some values for x that make the denominator 0. So in this case, x cannot be equal to 0. Here, we say x plus 5 cannot be equal to 0. And in order to get the value of x that makes this expression 0, we solve this as if it is an equation. And we get x equals to minus 5. So we say that implies x cannot be equal to minus 5. Similarly, with the last one, 6 over x squared minus 9, we factor here. That's the difference of two squares. And in this case, the values that make the denominator or this expression 0, those values are x equals to 3 or minus 3. And x cannot take these values. After doing our exclusions, we can do the simplification. And we simplify as if we are simplifying any fraction. Now, if I'm simplifying 6 over 8, you can see these two numbers are even numbers, and I can divide each one by 2. And we get 3 over 4. Now, if we are doing the same thing with the rational expressions, let's take an example. After factoring our numerator and denominator, let's say we get something like this. Here we have the same number in the denominator and in the numerator. X plus 5 and x plus 5. This is the same factor, same number. So I can cut this expression, but before I do anything, I have to put the exclusions. X cannot be minus 5 or minus 3. In case this is 0, that means x equals to minus 5, so x cannot be minus 5, and x cannot be minus 3. Now, after putting the exclusions, I can do the cutting. And we get x minus 4 over x plus 3. This is our answer. But we have also to include our exclusions. Here you can see that minus 3 will make the denominator equal to 0 and will make our expression undefined. But for someone who did not see your work and only seeing this part, he will not know why you are excluding minus 5. However, you must put this exclusion because this is carried from the initial work. And if you do not put this exclusion, then the teacher will deduct points for you. This is a must to put, even though now there is nothing that this number, x plus 5, is not there. And you might think there is no reason why x cannot be minus 5. If I put minus 5 here, that doesn't make the denominator 0. However, this was carried from the initial expression and it should stay there. And with this, we come to the end of this session and we hope to see you again.